This is the first video of the appendicular skeleton. I'm going to make two of them. First, we will cover the shoulder and arms and hands on this video. And you should watch this after you go through the appendicular lab study slides. And you should also have out your parts to know terms for the appendicular lab. All right, we'll start with the pectoral girdle, which, as we know, is the clavicle here, and the scapula, which is the shoulder blade from the anterior here, come around to the posterior. You can see it there. So the parts here of the clavicle, you just have to know the sternal end and the acromial end, where it attaches to the scapula. So if you remember the sternum here, the center of the chest, and the sternal end would fit right in here. That's the jugular notch of the manubrium here, part of the sternum. And you can see this edge is kind of a flat ending here. And then we come to the other end, the clavicle, and we can see that it's kind of rounded on the end here, and it meets this process, the most superior process of the scapula. Well, that's going to be the acromion process. And if you hear the word acromial, it means the tip of the shoulder. You tap on your own shoulder. That's the acromion process of the scapula. So you can see how this clavicle kind of is further anterior in the medial part, and then it curves back. And again, feel that on yourself. Put your hand on your sternum. Feel your clavicle, move it over, and see how it dips there, coming to the point on your shoulder, and you can feel that acromion process as well. Now moving to the scapula here. From the back, we could see the posterior spine here. You can feel that on yourself. And then we can see the acromion process here. And the other significant part here is the glenoid fossa, the dip here where the head of the humerus will fit in there. You'll be able to make all kinds of movements. The other part of the scapula is this coracoid process. Now, from the lateral, I'm seeing the acromion process with the clavicle attached. Now I'm seeing this coracoid process here. Now that's not articulating with another bone. So what's it for? Well, that's for a lot of muscle attachments there in the shoulder attached to that protrusion. So named the coracoid because it looks like a crow. Look at this angle. See how it looks like a crow? Crow's head. Here. Let me look on the sheet to make sure I covered all the scapula. Yes. All right, we'll move down to the humerus now. All right, let's get our distance perspective here. Right? Now on the humerus, we have the head, half dome. Notice that is smooth because it's covered with cartilage. Bones are covered with cartilage, which is a little softer than bone, where they meet another bone. So the lining of the glenoid fossa is smooth, covered with cartilage, and so is the head of the humerus. Then we have the neck part of the humerus, where the head joins the shaft here. Now, a significant protrusion here on the humerus is the deltoid tuberosity right here. And that's because the deltoid muscle is going to be attached up here, the clavicle and scapula. It's going to come down and attach to the humerus. And when that muscle contracts, it's going to pull this part of the humerus up, and you're going to move your arm out. That's called abduction. But all these lines, protrusions, extensions, they're for muscles to hook on. Remember, Wolff's law, bones are thicker where there's more forces put on them by the muscles. Let's move down to the distal part of the humerus here. And we can see a couple significant landmarks. This is going to be the trochlea. Looks like a spool of thread on the anterior. Let's make sure he's in the anatomical position here. I don't know if he'll stay there or not, but then we have here called the medial epicondyle. Okay, now I said when you have medial and lateral protrusions, almost always the medial sticks out more. Now, why is that called epicondyle? Because epi means on, and it's on these condyles here. Now we'll call on this part of the condyle the trochlea. This has a name we're not going to cover, but it is like a condyle there. So that's the medial epicondyle and the lateral. The medial sticks out more. You can feel that on yourself. Quite prominent. Come around to the back, we can see that we have here the olecranon fossa. Now this part of the ulna, this is going to be part of the ulna, that's called the olecranon process, and it fits into this olecranon fossa. As far as the trochlea, the ulna is also going to fit around that here. So this whole part, structure, with the trochlea and the olecranon fossa is going to make this nice hinge joint to let your forearm flex and extend. So the olecranon fossa has to be on the posterior, the humerus, because that's where the olecranon process of the ulna is. When you feel your elbow, that's what you're feeling, the olecranon process of the ulna fitting into the olecranon fossa of the humerus. Let's move to the forearm now. Okay, we're going to have two bones in the forearm here. And they're going to be the ulna and the radius. A couple ways of telling which is which. First of all, the radius always goes to the thumb. And you know, when we feel the radial pulse on somebody about right here, we name that the radial pulse because there's a radial artery there that goes along the radius, which goes to the thumb. Other way I can tell this is the radius is it has a circular, completely circular head here. So you think of the radius of a circle. The ulna goes to the pinky. And you can't really tell with the articulated skeleton too well, but I'll go to this one here. And you see that has a U-shaped notch there. I can see the circular head, the radius. But the ulna, when I show you this bone separately, it has this U-shaped notch here that fits around the humerus. So that's how I can tell that's the ulna. And also that it leads to the pinky. Okay. Now the other parts of the radius and ulna, we got the radius head. We have the radial tuberosity here. And that's going to fit right against the ulna, like that. And we have the styloid process. Now, a stylus, you know what a stylus is, like a little pen. And this little protrusion here is the stylus part. See it nicely here, of the radius. And if you feel by your pinky, wrist part towards your pinky, you can feel that stylus protruding there. As far as the ulna goes, well, we said we had the olecranon process in the back. Now this whole U-shaped notch here, since it fits around the trochlea, it's called the trochlear notch. We also have another notch in this area right here called the radial notch because the radius bone fits in there. And this radial notch, articulating with the radius head, allows us to rotate our forearm. So notches are named for the bone that articulates with them. Radial notch of the ulna articulates with the radius. The trochlear notch of the ulna articulates with the trochlea of the humerus. Those are the main parts of the ulna. I keep emphasizing that this joint here at the elbow, two kinds of joints. We have the hinge joint because of the ulnar humerus, involving that olecranon part. And then we have the rotating joint at the same place because of the radius ulna connection. Hinge due to the ulna humerus joint, rotation due to the radius ulna joint. Now the radius also does articulate against the humerus there to allow smoother rotation, as you can see. And again, notice how smooth this tip of the head is because it articulates the humerus. These notches are smooth, covered with cartilage, because they articulate with another bone. You can see the radial notch there nicely. So when you're in an anatomical position, the bones are lined up pretty much side by side. But when you rotate, the bones kind of cross over. Like that. Let's move to the hand wrist now. All right. We can see we have about 8 carpal bones there. And again, we're not going to learn the names of those. They all look pretty much the same. This one has a little protrusion here that you can feel on the anterior of your wrist. Carpal bones. And then when we get to the hand, right in front of the carpal bones are these long bones, and they are called metacarpals. That's where the palm of your hand is. Then we get down to the phalanges here. So there's 3 phalanges in all the fingers, except for the thumb, which only has 2 phalanges. If you forget that, look at your own hand. You can see how many bends you have in all the fingers, except for the thumb. You only have 2 bends there. So we name the phalanges. Distal phalanges, furthest distant from the attachment to the wrist. Medial or middle phalanges, and then proximal phalanges closest to the attachment to the palm or the wrist. On the skeleton, since you can't see the skin, some people confuse these as phalanges. They're not. That's where the palm of your hand would be. So always start down here, because you know there's 1, 2, 3 phalanges. Then you can know these are the metacarpals there. think that'll do it for the pectoral. Let's take a distant look again, how it all fits together.